All right, so look at my little note here. It says if you're not given a growth or decay function for your bacteria, radioactive substance, etc., so these are like conditions you'll have in your problem. If you're not given a function, it's okay to assume that our function has the usual form. So this is the same thing as our PERT function. A equals P times e to the RT. The variables just look a little different, so this is more of a science context. So typically we have a population of a substance, that's our P, and so P naught is our initial population. So that's the population we start with, just like the principal is the amount of money we start with. So P naught, that's the P sub 0, is the population we start with. K is our growth or decay constant. So it's the rate of growth or the rate of decay, just like the rate of money that's changing. All right, and then T is still time, and time could be years, but it might not be years. It's going to just be consistent units for the whole problem, like this when you see days, so time is going to be in days for this problem. All right, and then finally P is the population, so the ending amount. So it's the same form as PERT, but with different letters, and these letters have different names. Okay, so let's look at number 3. It says 75% of a radioactive material remains after 13 days. Find the decay constant. Okay, so let's start, before we go, let's think about what we're starting with and what's given in the problem. So let's look at our formula, our initial amount. Does this problem tell us anything about how much radioactive material we have at the beginning? It actually doesn't, so we are not going to use anything for that. We're going to call it P naught to say this is our initial amount. All right, what about the ending amount of radioactive material? Does the question tell us anything about the ending amount? Well, it says that 75% remains. Okay, so what is that saying? 75% of what? It's 75% of what we started with. So our ending amount is going to be 75% of our initial amount. Okay. And then time, they gave us 13 days. And we are asked to find K. That's what we're asked to find, the decay constant. All right, so now we know what we're given. Make sure you understand what's happening so far. All right, so let's set up an equation. All right, we want it to look like this. Same as always, our ending amount, which is 0.75 times the initial, equals the initial amount times E to the decay constant times our time. Okay, so it looks as if we have more than one variable, but things are going to work out. Why? Because we're trying to solve for K, which is in the exponent. So that means we need to isolate this exponential part by dividing both sides by P naught. So actually, the initial amount didn't really matter at all. All right, and so we know how to do this, right? We know how to solve for K. We can just take the natural log of both sides. E and natural log are inverse functions, so we're just going to be left with K times 13 over here. And now we just divide by 13. All right, and so this is our decay constant. And so notice it says do not round your answer. That's because we're going to use it in part B, and if we round now, our part B will not be accurate. Okay, So on a test or something like that, it is totally fine. I actually prefer if you leave your answer like this and not round it unless I say to round. Okay, let's look at part B. It says find the time in days, just like what's given, days, after the initial measurement when 15% of the original amount of radioactive material remains, round to the nearest whole number. Okay, it says find the time in days, so we want to find time. That's what we're looking for. After the initial measurement when 15% of the original amount remains. Okay, so let's go back, run through the things we need. We need the initial amount. We don't know it. That's fine. We need our ending amount. Well, it says 15% of the original is our ending amount. So 0.15 P naught. All right. Also, we need our decay constant. We found it in the previous problem. All right, so these are all the pieces. We're trying to find time. Now we just need to put it in our equation. Same equation as always. Our ending amount equals our initial amount times e to our rate, which is the natural log of 0.75 divided by 13, all of that's in the exponent, times our time, which is what we're trying to solve for. All right, so the thing we're trying to find is in the exponent of this exponential, so we need to isolate the exponential first. So we're going to divide both sides by our initial amount, P naught. Okay. All right, same song and dance. We know exactly how to solve this. We can take the natural log of both sides to bring our exponents down. Okay, e and natural log are inverses, so we're just left with the inside. All right, and we can solve for t by just dividing by this thing. All right, so this is totally fine as a final answer, or we know that dividing by a fraction means we need to multiply by its reciprocal, so we want to multiply by 13 over that. So it'll look like 13 natural log of 0.15 over natural log of 0.75 is our time. And so this is the thing we need to round to the nearest whole number. So this is our time we found. So we bring out our calculator. I'll do 13 times the natural log of 0.15. I'm going to divide it by the natural log of 0.75. All right, so I get that t is about 86 days. So what does this say? It's going to take 8 days for 15% of the original to remain.